This video is all about perpendicular lines. First, I'm going to tell you about what perpendicular lines are, and then I'll go through some common questions that are asked about perpendicular lines. So first, what are perpendicular lines? Well, perpendicular lines are a very specific set of lines that intersect at a right angle. And there's a specific symbol that we use to indicate that these lines meet at a right angle, and that is a box that looks like that. That means they intersect at a right angle, also known as a 90-degree angle. Now there's another special property about these lines, and that has to do with their slopes. So let's take a look at the slopes of these two lines. Let's call this line 1, and we will indicate that the slope of line 1 is equal to, well, let's pick a point. Let's go from here to, what's another good point here, and then it looks like it continues. And it looks like from here I would go down 2 and right 3, so my slope is -2/3. Let's take a look at line 2, at line 2's slope. So if I go from, let's look like this point to this point or this point, all right, the slope between those 2 points, I would rise 3 and run 2. So the slope of line 2 is a +3/2. All right, so let's take a closer look at these two slopes. Now, I've already told you that these lines are perpendicular, and in fact, I know that I have created perpendicular lines because these slopes are what are called opposite reciprocals. Let me go through what those two words mean. First, opposite. These slopes have to be opposite in sign. So one has to be positive and one has to be negative. Here, the slope of line 1 is negative and the slope of line 2 is positive. Great. It meets the fact that these are opposite. Now let's look at reciprocals. Reciprocals kind of mean just the fraction is flipped. So if the top one is 2 divided by 3, well, if I flip that, the bottom one is 3 divided by 2. So yes, they are opposite reciprocals. Now there's one more thing I wanted to point out, and a YouTube viewer, Jan, thank you so much for pointing this out about the slopes of perpendicular lines. If I multiply these two slopes together, let's take a look at that. -2/3 times 3/2. Let's see what the product of these two slopes gives me. Looks like I have -6 divided by 6, which is -1. In fact, this will always occur with the slopes of perpendicular lines. If you multiply the slopes of perpendicular lines, you will always get -1 because those slopes are opposite reciprocals and they will create that property. So thank you again, Jan, for pointing out that great point. Let's take a look at our first example. Here it says, if a line has a slope of -4, what is the slope of a line perpendicular to this line? Okay, so I want a slope that is perpendicular. I remember that those slopes are going to be opposite reciprocals. So the slope of this line is -4. Now, I'm actually going to use the strategy of writing this as a fraction so that I can take the reciprocal a little bit easier. -4 is the same as -4 divided by 1. All right, now let me go ahead and take the opposite reciprocal. Well, if the sign of the first slope is negative, I know my perpendicular slope will be positive. And then if I take the reciprocal or flip this fraction, I would get a slope of +1/4. So a slope of +1/4 is a slope that's perpendicular to a line that has a slope of -4. Next question are these two lines perpendicular? Well, in order to determine this, we need to look at those slopes. And both of these equations are written in slope-intercept form, which is y equals mx+ b. Therefore, I can find the slopes as the coefficient of x. So in the first line, the slope is -1/2. In the second line, the slope is -2. So in order to determine if these two lines are perpendicular, I need to figure out, are these two slopes opposite reciprocals? Well, I said the word opposite, and I see that's where they fail. Now, although these slopes are reciprocals, they are not opposite in sign. Notice both of these are negative. The slopes have to be both opposite and reciprocals in order to be perpendicular. So here our answer is no. Let's take a look at another example. This one says to write the equation of the line that passes through the point 4, -2 and is perpendicular to the line y equals -4x minus 9. We want to write a line that's perpendicular, write the equation of a line that's perpendicular. So if I look at the line I want it to be perpendicular to, remember that this is in slope-intercept form, and this equation has a slope of -4. If I want a slope that is perpendicular to this line, well, that's the question we did a couple times ago. That would need to be a slope of +1/4. All right, I'm going to take this time to mention something very important, and it's something that I see in class when I work with students. Oftentimes, students can identify the slope of 1/4, but they get really excited and want to jump right into slope-intercept form. So sometimes they may write, and once again, this is incorrect, sometimes they may go directly into writing, okay, the slope is 1/4 x, and I'm going to use this number, -9. That is incorrect. That is -9 is not the y-intercept of this new line. Well, it could be, but we can't assume that. Another thing I commonly see is students will use this y-coordinate and say -2. Once again, -2 is not the y-intercept of that second line. It's just the y-coordinate of a point that's on the line. So I just wanted to state some common mistakes that I see. Okay, so from here, I now know that my slope is 1/4 and a point on the line is 4, -2. And what I can do, since I have a point and a slope, I can use what's called point slope form, which is y minus y1 equals m times x minus x1. I can use 4 as my x1 and -2 as my y1. Plugging those numbers in, y minus a -2 will change to +2 equals the slope, 1/4 times x minus x1, which is 4. If it's okay to leave it in point slope form, that equation is totally fine for writing the equation of this line. Now, I did want to mention another way to do this, and once again, a YouTube viewer, Jan, pointed this out to me. Thank you so much for mentioning this, Jan, that we can also go to slope-intercept form. That is y equals mx plus b. Well, we can use the y-coordinate of our point, -2, use our slope of 1/4, use our x-coordinate of 4, and what we can do here is we can solve for b, the y-intercept. 1/4 times 4 is 1. Subtracting 1 on both sides gives me a y-intercept of -3. Therefore, going back to this form, my equation would be y equals my slope of 1/4 x minus 3. And you may think, wait a second, these two equations are not the same. However, if I go back to this equation right here, and I were to distribute the 1/4 into the parentheses and subtract the 2 over, I would, in fact, get the same slope-intercept equation in the end. So what I love about this is you can be very creative. I just threw my pen. Let me get that back. So you can be very creative with problems like this, and I love that about math. A lot of people think there's only one way to do a problem, but you can see here you can be very creative and solve the same problem in multiple ways. Let's look at one more example. In this example, we're writing the equation of the line that passes through the point -8, 7 and is perpendicular to this line y minus 6 equals 3/4 times x plus 1. This equation is written in point slope form, and if I want my line to be perpendicular to this line, I just need to alter this slope. That's the only thing I care about with the equation of that line. I can see the slope of this line is 3/4. So if I want to write the equation that's perpendicular to this line, I need to write a slope that is an opposite and a reciprocal of this one. So in that case, the slope would be -4/3. Now for this one, since we were starting in point slope form with what we were given, I'm going to go ahead and just leave this one in point slope form using this point and this slope. So once again, I will use y minus y1 equals m times x minus x1. Here's my x1 and here's my y1. So here I have y minus 7 equals my slope times x minus a -8. And there is my equation of the line that passes through -8, 7 and is perpendicular to the given line. Thank you so much for watching this video about perpendicular lines. I hope you found this useful to know what perpendicular lines are and then going through some common examples that you may see. Make sure to give it a thumbs up and subscribe so that you are notified of weekly math videos that are posted. Have a great day.